Okay, we're going to look at solving a couple equations. The first one will be a unit circle question, and the second one will be a calculator question. And you don't really know that going into it. You just have to know it's if you can use your unit circle, use it. If you can't, then use your calculator. Probably the first thing before you start is just pay attention to the directions. In this case, it says that, well, my computer didn't like that. It says that we're solving on 0 to 2 pi. And so you're going to be in radian mode. Okay, so then if you look at the question, when you solve an equation, the first thing you look at is the trig functions. Is there more than one? Are they the same? Are they different? What is it? In this case, there's only one trig function. If there's only one trig function, you want to get the trig function by itself. And so we're going to add the square root of 3 over, so 3 tangent x is equal to the square root of 3, and then divide by 3, and so I get tangent x is equal to the square root of 3 over 3. Now this is what we call the boss equation. This guy says some important stuff. The first thing this equation tells us is that tangent x is positive. Okay, so that's important, and we know something about tangent x being positive. We know that tangent x will be positive in quadrants 1, where everything is positive, and then also in quadrants 3. This is that all students take calc. So all my tangent function is positive down in quadrant 3 and also quadrant 1. So that's where I'm looking for answers. I'm looking for an angle that makes this statement true. Tangent of what angle is square root of 3 over 3? Okay, and that should look familiar because it's a unit circle value. And if you can't remember which one, just try a couple. It's got to be either this one or this one because we have a square root of 3 in it. And hopefully you remember which one is square root of 3 over 3, but if not, let's just try one. So tangent is sine over cosine, or y over x. So if I use, let's not use this one, if I do 1/2 over square root of 3 over 2, then I rewrite the top, multiply by the reciprocal, and sure enough, I get 1 over square root of 3, which is square root of 3 over 3. And some of these values on the unit circle will be easy to just like pick out and see. In this case, it took a little work. And so the angle that makes that true is pi over 6. And so that means tangent of pi over 6 is square root of 3 over 3. So that is one value for x. That's the value in quadrant 1 is pi over 6. Now I also have an answer in quadrant 3 because tangent is positive in quadrant 3. And so I can use that same reference angle. I know it's going to be over 6 in quadrant 3, so it's got to be 7 pi over 6. We can move these reference angles around, and so there are my two solutions for this equation. Okay, let's look at number 2. Number 2, so once again, there's only one trig function, so I can get this function by itself just by subtracting 1 and dividing by 3, and that gives me sine theta is equal to -1 and then divide by 3. So sine theta is equal to -1/3. Okay, so that's a little bit tricky to handle because -1/3 is not on the unit circle. So we have to first decide the quadrants we are looking in. And so sine theta is negative in quadrants 3 and 4. So I'm looking down in quadrants 3 and 4. What I usually like to do, because someone showed me this, is to draw a little coordinate plane and just like draw a couple of triangles down in 3 and 4, or just like label 3 and 4. Sometimes the triangle visual will help. That kind of goes back to things we've done in chapters 1 and chapter 2 even. But those were all my answers. Now I don't have a way to know what sine theta or what the angle is except for using the inverse. So I can use the inverse to find the angle. So I can do sine inverse of -1/3. And I type that in my calculator, and let's round it a little bit. Let's keep we'll just keep 2 decimals. We'll say -0.34. when you type that in. And sine inverse is the second sine key, so it's right above sine on your calculator. Okay, but there's just a problem with this answer because we want this answer in between 0 and 2 pi, and this is negative, so it's lower than 0. It still makes the equation true, and part of that reason is that I can just keep going around the circle forever, or the graph of sine goes forever, so there will be an infinite number of solutions. But we just want a couple of them. We just want the ones that are in quadrants 3 and 4 the first time around. Okay, so now we have to use what we know about reference angles. So let's kind of redraw our picture a little bit bigger. And what that means is that this angle is 0.34. It also means that this angle right here is 0.34 radians. And so I can use 2 pi and pi to find the angle in quadrants 3 and 4. So to find the angle in quadrant 3, I'm going to use the positive version, so I'm going to kind of say that the reference angle, let's write that down. So the reference angle is 0.34. And you don't have to go to the positive version. There's other shortcuts you can take. But if you take the positive version, you have more consistency throughout your problems. So in quadrant 3, we're going to do pi plus 0.34. And in quadrant 4, we're going to do 2 pi minus 0.34. And then those would be numbers you just type in your calculator. So it looks like I got 3.48. We'll just do 2 decimals. And then 2 pi minus 0.34 would be 5.94. And so your theta here is 3.48 and then 5.94.